Good evening, everyone. I'm Prasija, and it is my pleasure to welcome you to all the fourth day of our lecture series on the topic Semiconducting Oligo Octanes from the Ghazipur landfill. Before we begin, I would like to remind you that if you have any questions, please submit them through the chat box. Now it is my honor to invite Professor Eswaran to deliver today's lecture. Thank you.
Once again, good evening to one and all present. We are on a different theme today. The title can be split into two parts. The very controversial Ghazipur landfill in East Delhi. I repeat, the controversial Ghazipur landfill, almost a monster like a mountain structure in the east of Delhi. There are many such landfills around Delhi. But the other part looks more scientific. Semiconducting. Semiconducting means, I think it's somewhere the borderline between physics and chemistry, maybe more physics. You can hear me, I hope. So, semiconducting, what is Oligo? Oligo means a kind of a short polymer. How many? 8 units. 8 means if there is a octyne, that means there is a triple bond. Triple bond is between 2 carbons. That means when it is octa, that means you see one A has been removed because there are 2 vowels there. Octyne, it is not octynes. So 8 into 2 means 16 carbon chain. Today we are talking about the work done on the Ghazipur landfill inert soil. Around the month of April 2021, I saw an advertisement in the local newspapers from the Municipal Corporation of Delhi that one can get so many tons of this landfill inert soil at 100 rupees, just 100 rupees. So I asked one of us to go and get the thing, but one could not arrange to bring a ton or 2 or 10 tons, though we were offered subsequently that much amount. That means 10 truckloads every day, which I, as a teacher, could not say yes to. The Ghazipur landfill, you will see some photographs of it shortly, is a very, very hot topic in the city of Delhi. But I'm looking at it from a purely scientific viewpoint, so I shall refrain from making any comments on the other aspects of the problem. So many of us are aware of it. Oligo means short polymer-like compound. Octynes means 8 into 2, 16 carbon atoms. I hypothesized that we could isolate from this waste material. There is a policy of the government of India, waste to wealth. But let me say that we have not taken any financial support, any grants from any government agency for doing this work. It must be stated in very clear terms that this is done with our funds. We asked the question, first of all, we were asking the questions, can we make some useful things from this landfill inert soil, which is available in tons and tons from just this one landfill. There are other landfills around Delhi and such landfills all over the country and in the rest of the world. I hypothesized after getting our spectroscopic data, to which we'll make a reference, and that the hydrogen to carbon ratio from the molecular weight, the molecular formula that we were able to derive, that the hydrogen to carbon ratio can only be explained if we had a lot of unsaturation. And the lot of unsaturation means not just double bonds, but possibly triple bonds. And you all understand that triple bonds can't be one after the other. There must be another kind of a bond, preferably a single bond between the 2 sets of triple bonds. So it's triple bond, single bond, triple bond, single bond, triple bond, single bond, 8 into 2, 16 carbon atoms. This was a hypothesis. This remains a hypothesis. Then what good would come from doing this work was also a question among the questions that are raised in the next slide, which you will see. I don't have to read all the questions. You can read it yourself. Is it going to be of any use to work on this material? The question is that the government of India has taken it very seriously to look after this big monster-like mountain in East Delhi. And I say that we eventually have isolated Oligo Octynes. How is it connected to landfill? And also that around the time 2000, when I was in college, first early morning, two sets of us groups left for the National Physical Laboratory and to hear the two Nobel laureates of that year who were there visiting and giving talks. The third one I met in Hyderabad. Now, do the compounds that we have isolated actually show semiconductor-like property? One of my students present here has been saying that, in fact, as happened in the case of Nobel Prize 2000, that polyacetylenes were conducting polymers. Polyacetylenes were conducting polymers. Another organic material called polyaniline was a conducting polymer. But polyaniline had to be, protonated before the charge could move across the molecule, the large molecule, for conducting or semiconducting properties to be observed. Yet at the same time, the polyacetylenes, which were the focus of 2000 Nobel Prize in Chemistry, required that you dope it with something like bromine or iodine. So when doping happens, the conductivity dramatically increases. So I have raised the questions and the contents of this talk, but some part of the talk may not be clear unless I explain. That is the need for a lecture. Otherwise, why should we have a lecture at all? But this part, some part of it has been published by us. Another paper is with the journal for about a couple of months. So we hope to hear from them soon. And of course, we have patented this. The granting of the patent takes many years. So maybe a couple of years down the road, we will get the patent. It's only an Indian patent. We have not applied for a US patent because there is, strictly speaking, no need. It is no longer the old case. Even if you patent in India, it's valid all over the world. See, what we are trying to see is, what is this landfill? All kinds of municipal city solid waste is collected, transported, and much of it falls around as you are going around and in the city itself, causing pollution. And you see, it pollutes the soil, the leachates from this pahadi, if I may call it, and lots of toxic gases. Some are mentioned here: carbon dioxide and say carbon monoxide, formaldehyde, hydrogen sulfide, and ammonia, presumably even methane. These could cause respiratory diseases. There is a link to cancer, and also that there is other kind of diseases like cardiovascular diseases. And this entire thing occasionally catches fire. In this lecture today, we will focus only two parts. We will focus on that brain part towards the end if we have the time. And we'll focus also on the ability of these materials to conduct. The results that you will hear during this talk is based on a lot of spectroscopic data, particularly the mass spectral data given to us twice from the Indian Institute of Chemical Technology, Hyderabad, a CSIR laboratory. Dr. Sripadi Prabhakar gave us such wonderful mass spectra that we could build on our initial hypothesis. We go on, that means this can impact life in a variety of ways. And those living in East Delhi or having gone there would know what I'm talking about. Next slide shows us that, you see, this is how muggy and smoky this whole place looks like. Maybe this is a picture taken in the winter months, but it occasionally catches fire. The next slide. The government has done some very good work. They have converted this material into bricks and used it for, laying roads. There's a good initiative on the part of the government. There is a big structure. But what we did was something different. We wanted a different approach. So in the next slide, you are shown something that we have isolated from this Pahadi, from the Ghazipur landfill inert soil. We have isolated a compound which we have not named in a popular manner. You will see the letters GLF in our entire presentation. So GLF represents Ghazipur landfill. And that is the landfill inert soil that we were given for free. And at a later stage, I met an IAS official who was the municipal commissioner. He made me present my work to the then done work to his officials. They said, can you take per day 10 trucks of this material? I said, I'm a teacher, I'm a scientist. I don't have the wherewithal to deal with such huge amounts. So there it stayed. This is our starting material. You see, a chemist immediately is interested in purity. We isolated under different pH conditions 3 compounds. This mass spectra came from IICT, Indian Institute of Chemical Technology, Hyderabad. These were named by me as GLF NSIC 14. NSIC stands for the place where we had lab, our lab, till 30th of September 2024. On the 1st of October 2024, we have moved our entire lab to FITT IIT Delhi, where each one of you is welcome. GLF NSIC 14, 14 refers to the pH at which this compound is obtained. Before that, we have GLF NSIC without the letter 14. And then we have mere GLF, 3 compounds isolated from this, which we have analyzed by most modern methods, and we have interesting results to announce and tell you. See, a proposed structure is shown here, where you see this molecule looking like, somebody says like a walking stick, somebody else said like an umbrella, which can be folded and kept in your hand, the top part, and the long chain of triple bonds. Hey, what is this? Is it very similar to polyacetylene? Sir, what are you trying to tell us? That you isolated some, not polymeric, but oligomeric acetylenes, which could be conducting or semiconducting, which could be used for making devices. Yes, this is precisely what I'm pointing at. Please remember, no money from government of India has been spent on this work. It's very interesting. Sociologically, it's very interesting that a man who is working hard is totally unsupported. But there are a number of young people, I'm sure, in the audience who would like to jump and come to us and share the spoils, work out the structures, because these are proposed structures. By the word proposed structures, based on mass spectrometry, NMR spectrometry, spectroscopy, H1 NMR spectroscopy, FTIR infrared spectroscopy, and ultraviolet visible spectroscopy, and so on. The compound in the middle is a little more colored, so its UV spectrum should be somewhat different from the spectra, UV spectra of the other 2, which are almost colorless. As we see, as we go, I hope you're focused enough on the structure. If you notice, there is a long chain of triple bonds, and there is a cyclopropane or cyclopropene ring. You have to focus and see the three-membered ring on which is attached a large structure. And it contains number of polar groups. It contains, among other things, for that matter, carboxylic acid groups, carbonyls, alpha keto acids, and in one of the cases, the amino group of the amino acid is present as a formylated amino group, that is NHCHO. Sir, क्या बता रहे हैं? हम तो सेकेंड ईयर में पढ़ते हैं, हम तो फर्स्ट ईयर में पढ़ रहे हैं, हमें तो ये कुछ आता ही नहीं, हमने स्पेक्ट्रोस्कोपी ज्यादा नहीं पढ़ी है. I'm not trying to impress you on subjects which you do not know. I'm trying to say कुछ अच्छी चीजें हमें वहां से मिली हैं, तो क्या वो प्योर हैं? Are they pure? Have we been able to characterize them? Based on the spectroscopy data, we have taken courage to propose these structures. The work is not finished. Work never gets finished. If you produce one PhD, 4 PhDs get produced of that PhD. You produce one paper, good quality paper, any number of papers get published following that because you keep asking questions. मैं रोकता हूं अपने टॉक में. सर, आपके पास एविडेंस क्या है कि इतने सारे ट्रिपल बॉन्ड्स हैं? What is the evidence you have, sir, that there are so many triple bonds and that these triple bonds are linearly arranged? Proof है आपके पास? सर, ऊपर वाले स्ट्रक्चर का प्रूफ कैसे आपके पास? मैं जानता हूं प्रूफ एक अल्टीमेट प्रूफ होगा यदि प्रोफेसर विश्वामित्रा मेरे साथ आज काम कर रहे होते, जैसे उन्होंने विश्वमयी में काम किया, the way he helped me with the structure of Vishwamayi, then he would have given us an X-ray structure. One of our students is trying to crystallize some of these compounds so that they can be put inside and an X-ray diffractometer can be used and we can find out the X-ray diffraction pattern and work out the structure and confirm the structure or disprove the structure. There is another technique which is very useful these days. All the various methods of two-dimensional NMR spectroscopy. But it's very difficult to get these spectra recorded because unless you are there at the instrument, most of the people who are running the instruments are technicians. They are scientific technicians, but they are not scientists. Even sometimes, if the scientist gets attached to an instrument for the whole life, he or she loses his or her science. He only knows the instrument, but he does not know, or he or she may not know what are the questions being asked. The questions being asked, can you prove presence of a triple bond? NMR spectroscopy is of little or no use. There is only one hydrogen at the end of the chain which one can catch. Nothing else. The top part is a very rich part for NMR spectroscopy. But then one-dimensional NMR spectroscopy is not enough. We need two-dimensional NMR spectroscopy. My student has written a small caption there. Has anyone seen this molecule before? I will expect an answer from the select group later in the question answer session. मेरे मुताबिक ऐसा molecule, I happily state, such a molecule has not been described, I underline, has not been described before. We have these compounds in gram quantities. When my student went and they gave him, he brought 10 kilograms for free, traveling by a three-wheeler. And the next day he reported that he was down with that, disease that everybody caught hold of during the COVID times. He suffered that disease twice, came back, continued to work in the lab. And these compounds were isolated in my presence. I was present each time, how to change the pH and so on. So next slide should show you once again, as I presume. Can we see that? Once again, you will see the photographs. Oh, this is a ninhydrine test, but there is no purple color. But nobody can deny that there is a color. I don't want to know which color, but it's not colorless. That means it is showing a ninhydrine test. Oh, that means this amino acid is not like the other amino acids which are used to make up our body or all forms of life on earth. This is also possibly once again, as we will be talking tomorrow, another such compound which we call as non-proteinogenic amino acids. Non-proteinogenic amino acids. Many of them are present on the surface of Earth. On Earth, we do not know why they are present, because we presume all forms of life are made based on only the 20 or 21 amino acids. How untrue it may be. When you determine the same compounds or find the same compounds on the surface of Mars or Jupiter or in deep outer space, then we will be revisiting. So I told you the other day, we'd like to have its Raman spectrum recorded and put the data on the Mars rover. देखिए, हमारे दोस्त ने बहुत अच्छा 3 स्पेक्ट्रा हमको दिखाए, मालडी MS स्पेक्ट्रा from IICT Hyderabad under high resolution. And in one of these cases, the value is 624. The other value, high value, is 596. In the third case, the value is 540. Now, I know you may not know that 624 is to be read as 625. 596 is to be read as 597. 540 is to be read as 541. And if you see the difference between 625 and 597, or between 624 and 596, is 20 mass units, atomic mass units. What is 28? 28. What is 28 atomic mass units? 12 होते हैं कार्बन के, 16 होते हैं ऑक्सीजन. Aha, the molecule is losing carbon monoxide. हाँ, ये alpha keto acid की property है. It is known in first year, second year, alpha keto acids lose carbon monoxide. Achha, what is the difference between 540 and 596? Please note this. It is 56. It is 28 into 2. Oh, the molecule with a molecular weight of not 624, 625 loses carbon monoxide, first of all, and then it loses 2 carbon monoxide units from its top part of the structure. And we have to accommodate that in the proposed structure. I don't want to lose my audience. This molecule, NSIC14, presumably loses 1 molecule of carbon monoxide followed by 2 molecules of carbon monoxide. The first one is NSIC14. The second one is NSIC, and the third one presumably should be GLF. So we have already data from this very important technique, mass spectrometry, and such miniaturized mass spectrometers have been sent in the rover. So the rovers will pick up a little of the soil and they will collect the soil. At the same time, they will record the mass spectrum. And the mass spectrum or Raman spectrum or infrared spectrum, the data that we have collected, if it is sent by one of my students, I hope from the audience, somebody takes the initiative and sends it to NASA. NASA will, or ISRO will put it in their database. And then they will say, oh, so-and-so in St. Stephen's College, he was giving a talk and he said such compounds may be present on the surface of Jupiter or Mars or somewhere deep in outer space. Maybe some form of life, exo-life, may be dependent on this. Next point, next slide shows you, I hope. You see, this is a little more detailed explanation of how we explain parts of this molecule fragmenting in the mass spectrometer. There is the oxy, hexa, deca, octine unit shown on the left, which has a value of 209.003. Then there is a 4-methoxy acetoglyoxylic acid unit, and also you have a molecular weight of 144.006. The one here has a molecular weight which I can't read. You will note below the large structure, and here you have a 4-oxo 2-dehydroglutamic acid unit. Glutamic acid is one of the 21 amino acids known to go into the formation of the human body. If it's not glutamic acid, it's glutaric acid is the common dicarboxylic acid. When it is glutamic acid, then you know that it is an amino acid used in the human body. This is the way the molecule is broken into parts, into fragments. It is nothing like and I'm telling you, some people do Sudoku. Some people do crossword puzzles. In our St. Stephen's College staff room, we had Dr. S.R. Nagpal. He's very senior in age. He lives in Aurobindo Ashram in Pondicherry. Well into his 90s, I presume. Dresses only in pure white dress. He was the head of the department, mathematics in St. Stephen's College. Before that, Professor Bhattacharya, P.B. Bhattacharya was the head. And Dr. Nagpal. And the question was, is Dr. Nagpal or is he Nagpal? And Dr. Nagpal was a PhD from Harvard. To a student, to a PhD from Harvard, you don't talk to him. He talks to you. But he will get some younger lecturers to sit around him and they'll be doing crossword puzzles. Some people like to do Sudokus because it keeps your brain active. I tell you, ye to sabka baat. This is far more complicated. How to take apart molecular fragments from a mass spectrometer result, which is only numbers. What is lost? Carbon monoxide lost. Another carbon monoxide lost. Another carbon monoxide lost. How do you get all these things as a puzzle and put them together and suggest a structure? I'm telling you, there are many other fragments which I have not referred to. This will take an entire lecture to explain. But only simple statement is these parts, the values are seen in the mass spectrometer during fragmentation. So we put the jigsaw puzzle together and get the structure of our compound. But still, it remains a proposed structure because this has to be confirmed by many, many spectroscopic techniques, which you will read in the third year. And as you go on to do your MSc, PhD, and so on, I hope there are seniors and elders. I can't see who all are present. So they may possibly be interested in understanding this in more detail. Next slide shows you. You see on the left-hand side, you are seeing FTIR spectrum. Then you are seeing here I presume, the UV spectrum. UV spectrum and of the different compounds that we have studied. This is indicative of high unsaturation, which indicated towards the presence of triple bonds. Chemists can't see triple bonds. Chemists can't see triple bonds. But chemists can sense the presence of triple bonds, double bonds, single bonds. Next slide. This is the NMR spectrum of the different compounds. And in one of these cases, you will see a very interesting signal centered at 8.013 ppm parts per million, which clearly indicates the presence of an N-formyl. N-formyl means NCHO. O. That means the formyl group can do carbon monoxide, CO. NHCHO. Oh, it can do CO, carbon monoxide. This is exactly what I propose happened in NSIC 14 in the mass spectrometer when it lost its first molecule of carbon monoxide. Am I saying that this only happens in the mass spectrometer? Suppose it were to be happening in the landfill. Carbon monoxide is so poisonous. I hope you understand. I said I will keep clear of these issues, but there is a very strong possibility that this monster of a mountain, among other things, produces carbon monoxide, carbon dioxide, methane, formaldehyde, ammonia. In which case, these are not very welcome where human beings are living. Over and above this, the soil is also polluted, say. Leachate from this monster of a mountain can certainly disturb the ecosystem. Next slide. These are all experimental evidence. The proposed structures of the three compounds are shown in this slide. And that is the name given at the bottom is the systematic name, which is, I think, 1 mile long. So my student has written that someday that name may become part of the textbook, and tomorrow or day after or 10 years from today, this may be part of a UGC NET examination. Name this molecule. I'm not saying 12th class, but when you are going to higher level examinations, somebody may ask you to name this molecule. It is a mouthful, and I don't think I want any one of you to read it. NSIC 14, GLF standing for Ghazipur Landfill, National Small Scale Industry Corporation. 14 for PH, similarly without the number 14 and the mere GLF. They differ from each other, as you understand. Only the difference is the number of carbon monoxide units lost. All are prepared from the same source, Ghazipur landfill inert solid. Next slide. Don't try to go into the details. This is how it looks like. I don't know whether it's to be called a walking stick or is it a folded umbrella. I do not. Now we are going to ask questions around this molecule which is shown. Oh, that's interesting. That means the question is, there is a triple bond, single bond, triple bond, single bond, triple bond, single bond. Then these may be like polyacetylene, which are called conductive polymers. And I met all the three Nobel laureates, two of them in the National Physical Laboratory, and he's right in the middle. And then the Japanese I met in Hyderabad, in IICT. I heard his talk. And on the same day, I heard two talks by Alan Heger, one in NPL, one in Jorbagh in Delhi. So at the end of the lecture, second lecture, I went up and told, please go back to the last slide. In the second lecture, I asked him at the end, I told him, sir, I heard two of your lectures on the same day. He said, you must have been very bored. I said, I enjoyed, I learned a lot from you. And he says, I think that was 9th or 8th of October that year. He says, I was a physicist. The day I was given a Nobel Prize in chemistry, I became a chemist. A transformation that happened overnight. The man on the left-hand side, Alan Heger, he knew no chemistry, but was named a chemist because of the work that he did. There are stories written about this in my book, Grandpa's Noble Tales. Alan McDiarmid, the next slide, shot taken in the National Physical Laboratory, New Delhi. Right in the middle, he was given a garland of sandalwood. So he refused to take it off. So he's covered with a sandalwood garland, and he liked it very much. On his right is a former student of ours, and then the bearded man, late Dr. Forrest Jacob, a physicist in St. Stephen's College. He taught physics, but he was equally at home in Shakespeare. I do not remember all the names of the students, but just behind Dr. Jacob on his right-hand side, the young man went to Harvard. The next one went to Brown University. The one just above that young lady, is doing tremendous job in MRC, Cambridge. He's publishing in Nature, and so on. All the other students, you can possibly recognize me. I'm usually very careful in Delhi winter. So I have not only a jacket and a woolen pant, but also a scarf. My topi is missing, but I don't have a garland of sandalwood. Every one of the students has become a scientist. Do you get the message? You do some work, small work in college, go and listen to young Nobel laureates, interact with them, go with your professors, whether there's transport or not, walk the distance, take a bus or a metro. I think we didn't have metros at that time, but we went by two taxis, two cabs, and some came independently. This is a select group of students from each one of them is from the chemistry department, St. Stephen's College. I can remember some names. The one just on top of that young lady I told you, that's Tanmay Bharat. And he's done so tremendously well as a scientist. Other names can be picked up. So I think the moral of the story is do science, see the world, interact with people who have done excellent work. That should trigger some things inside you that you yourself produce remarkable work. The next slides are asked questions which are more difficult. So I'm not going to elaborate. You see, it's not only polyacetylenes, but you have polyanilenes, you have polypyrrole, you have so many other compounds, but they have to be either doped or, transformed in some manner like polyaniline. It will depend on the pH, I presume. I do not know whether one of our very senior people has joined us today. We will ask the question at the end. He had said he may, in which case I'd like to go down to him because he knows so much more about this subject from a physicist's viewpoint. And he was director of National Physical Laboratory, New Delhi, and he was also director of the Solid State Physics Laboratory, Dimarpur, and he's been very kind to me. He's remarkable. He's written a very huge book on this subject. Next slide. You see, this instrument was used recently by us in INUP, where we were given a project after a lot of scrutiny. It's called, I think, India or Innovation. I'm sorry, forget the N stands for Nano Users Program. India Nano Users Program. And here, GLF NSIC shows that curve on the left, that it is showing conductivity of the order of 10 raised to power minus 5 Siemens per centimeter, which is a very good result without any doping. If I'm to believe my student, even other molecules previously known like polyaniline and so on have the value of about 10 raised to power minus 10. This in its native state is showing a conductivity of the order of 10 raised to power minus 5 Siemens per centimeter. We are not doped it yet. After doping, it is expected to increase dramatically. The question my young friend is asking, will it behave like a metal after doping? Next slide. You see, these are various quotations. I don't know. I'm not going to read all of it. Undoped polyaniline has a conductivity of 6.28 into 10 raised to power minus 11 Siemens per centimeter, whereas the conductivity of 4.60 into 10 raised to power minus 7 Siemens per centimeter can be achieved by doping with 4% hydrogen bromide. Our compounds are water soluble. They can be processed. They are showing a value of 10 raised to power minus 5 Siemens per centimeter in the undoped state. Much promise. Hard work lies ahead of us. How many of us present in this audience today are part of this extended team? Next slide. Will show you that as we go to the next slide, yes, if the doping experiment, which we have not done, like with bromine, you can dope, or with iodine, you can dope. But there are other methods also, and it is expected that the values of electronic conductivity will dramatically increase. Doping experiment is yet to be done. Very soon, we should be able to get it done, one place or the other in table. Next slide. Why are you doing all this work? See, this is a paper published some time ago entitled Structure Conductivity Relationship of Iodine Doped Polyaniline. That means one can read this paper and you may do it with bromine, but bromine is even more harmful, difficult to put it in a lab. Iodine may be a little less harmful if you keep it in a, fume cupboard. Next slide. Computational studies. This is a slightly different twist to the game. Slightly different twist to the game. Computational studies, which I must call as initial computational studies, show that these oligoacetylenes possess very high dipole moment, value equating that of sodium chloride. क्या बात कर रहे हैं? ये organic compounds, covalent compounds, इसका डाइपोल मूवमेंट सोडियम क्लोराइड का मैं सवाल पूछूंगा, क्वेश्चन आंसर में आप जवाब दीजिए कि सोडियम क्लोराइड का डाइपोल मूवमेंट होता कितना है, कि इससे ज्यादा है। ये मैं नहीं कह रहा हूं, कंप्यूटर सॉफ्टवेयर बता रहा है। क्या बता रहा है? द कंप्यूटेशनल स्टडी शोज दैट दिस मॉलिक्यूल हैज पुट आउट these molecules will have very high dipole moment. That is why we said, let us go. I again mentioned Dr. Vikram Kumar's name. He mentioned that we go to NPL. We went to NPL, but we were not able to do much work there. But we managed to do it in INUP, IIT Delhi. अभी dipole moment हम बचपन से सीखते रहते हैं। हम में से कितनों ने, how many of us have actually done? I'm not saying how many of us have calculated using a computer. I'm saying how many of us have done a measurement of a dipole moment. हमारे पास ये compound इतने रखे हैं, इतनी मात्रा में, we have so much of these compounds that these studies can be easily done. How many of us have determined isoelectric points of amino acids? It can be done by titration, it can be done by many other methods, but I myself have not done an isoelectric point measurement. Next slide. तो इनके uses क्या है? सुपर कैपेसिटर बना सकते। अच्छा, और यहां से हम ऑर्गेनिक फील्ड इफेक्ट ट्रांजिस्टर्स बना सकते, सेंसर्स बना सकते। अच्छा, सेंसर्स, बायो सेंसर्स बना सकते। एंड इनको शायद, अभी मैं नहीं कहता हूं इस्तेमाल हो सकता है, इनको शायद नैनो और माइक्रो लिथोग्राफी में यूज किया जा सकता है। पर खतरे की बात और बहुत अचरज की बात अगले स्लाइडों में आएगी। ये दो तरफा तलवार है। ये तो क्या है, इसको कहते हैं कंडक्टिव पॉलीमर्स फॉर एडवांस्ड माइक्रो एंड नैनो फैब्रिकेशन प्रोसेसेस। अच्छा, ये कंपाउंड शायद नैनो फैब्रिकेशन में, माइक्रो फैब्रिकेशन में यूज कर सकते हैं। मैं तो निरा केमिस्ट हूँ भाई, मेरे को मॉलिक्यूल्स बनाना आता, पर मैंने फोटोरेसिस्ट पे आपको 1 घंटे कहानी सुनाई थी। अब हम नैनो लिथोग्राफी की सुनाएंगे और सुनाई थी और बोलते रहेंगे। पर ये हम कह रहे हैं, ये कूड़ा जो है गाजीपुर लैंडफिल में, उससे हम शायद नैनो फैब्रिकेशन ऑफ डिवाइसेस बना सकते हैं, नैनो डिवाइसेस बना सकते हैं। अरे नैनो डिवाइसेस का फायदा क्या है? नैनो कार बनाया था, किसने बनाया था भाई? जो सेंट स्टीफेंस आए थे, उसके बाद उनको नोबेल प्राइज मिला। मैंने बताया था, बेन फेरिंगा made a nano car and showed it in his Nobel lecture. You can attend and see the Nobel lecture on the internet. A small car which can move with your control, with your remote, inside your artery, and goes and fixes a superstar, Indian film superstar, is admitted to a Chennai hospital, and they did some process or procedure on him. He had a renal, that is kidney transplant a couple of years ago. And he had other problems. Now he has some swelling in one of his, you see, either abdomen or somewhere. So they have inserted a kind of what do you call it these days, stent, and then they have removed the problem. He'll be shifted to the general ward in a day or two. He's considered a superstar, and the doctor says once again that the superstar is not only a superstar in movies, but he is a superstar as a patient because he is healing himself so quickly. भैया छोटा सा मोटराइज्ड व्हीकल हो, इतना छोटा नैनो साइज का, आप उसको कैथेटर के साथ डाल के हार्ट के पास जाके जहां क्लॉगिंग है या स्वेलिंग है, उसको ठीक कर दें। अच्छा, मेडिसिन में भी यूज हो सकता है। नॉन सर्जिकल, इन्वेसिव बट नॉट सर्जिकल। नेक्स्ट स्लाइड। सो हमने इसको टेस्ट करा। कहाँ? एक टेस्ट करने के लिए बहुत पैसे देने पड़ते। Reliance Life Sciences, Mumbai. What does this table show you? GLF, NSIC, and different concentrations shown on the left shows no cytotoxicity. The government should be very happy. अच्छा चलो इसे कंपाउंड निकला वो टॉक्सिक तो नहीं, डर था ना ये टॉक्सिक होगा। पर बड़ी अचरज की, आई होप यू अंडरस्टैंड दिस टेबल, the values are all negative and so on, and cell survival is very high, very positive. Then toxicity is almost not there, and viability, normal cells are surviving and thriving. Next slide will show you something very interesting. And this has been done by molecular docking studies. This is done by Dr. Shailendra Astana for us in the Translational Health Science Technology Institute at Faridabad. Our molecule fits beautifully into this serotonin 2A receptor. What is that 5-HT2AR? And has a PDB in the X-ray data, this number 6A93. Question is, computational work shows that this fits perfectly into that particular serotonin receptor. Many of you know serotonin is a neurotransmitter in our brain. And whenever you get up in the morning, say, "Yaar, aaj sir mein dard hai," then you may have already realized that the amount of serotonin formed in your body, in your brain, from tryptophan, the amino acid, by some process. I had talked about another pathway the other day in a previous lecture. Serotonin is formed from tryptophan, one of the very common amino acids in the human body, and serotonin is a neurotransmitter. इस neurotransmitter के receptor में हमारा molecule fit हो रहा है perfectly. I can't read the docking score, but it is very good. One of my students will read the docking score shortly to you. That means our computational work shows that, and the amino acids that binds to is also possibly shown on this side, in the extreme right-hand side, which are the amino acids to which this molecule binds in the binding pocket of serotonin 2A receptor. Do you mean to say we have already submitted an abstract on this to the American Chemical Society spring meeting in San Diego, March 2025, where we are saying our compounds obtained from the Ghazipur landfill inert soil could very much be useful for treating Alzheimer's or Parkinson's disease or dementia. We were talking of electrical conductivity, we were talking of dipole moment, we were talking of mass spectra, we were talking of NMR spectroscopy, we were talking of other spectral techniques. Suddenly, we have come to these molecules being candidates. I hope this is somewhat true and not the reverse of it. If these compounds come out of the pahadi, they may cause diseases in human beings. So I don't want to overstate this case that our molecule will cure. I hope these molecules do not escape from the Ghazipur landfill and carbon monoxide, ammonia, formaldehyde, carbon monoxide, carbon dioxide, methane. And in addition, if suppose these damage the brain. No, I hope they do the other way, namely they cure people suffering from such diseases. I think we are almost, as we have completed nearly 3/4 of an hour or so, we are near the end of our lecture. So I hope those present, precious number of people who are present, would ask some relevant questions. Is there a slide beyond this as well? Oh, this is another three-dimensional view, molecular docking studies with our compound with acetylcholinesterase. The X-ray data bank shows this as 1-ACJ. Again, the docking scores are very good, and it appears that computational work shows that these may be useful in treating neurodegenerative diseases. We imagined that neurodegenerative diseases affect only older people, but depression, clinical depression, is affecting such a large number of people. You remember that young employee of Ernst & Young died within 3 months of joining the company because of overwork. Many students are finding difficult to cope up with their studies. Even not only in schools and colleges, even in the IITs, it's not a number of dropouts going away, but number of young people either, sorry to say that, I don't want to be sounding very negative at all, but so many suicides all over the country, especially in a pocket in Rajasthan. So many suicides in IITs. That means the mental health of young people is very crucial. That is where a college like St. Stephen's, I hope other colleges follow this, provides a kind of a loco parentis. The teachers are not there to stuff the brain with data and information. They want to teach, make people learn, at the same time, learn in a very relaxed manner. I hope these 3/4 of an hour that you heard me, I was not under tension or pressure. I was quite relaxed. I knew what I am to tell you. I am to tell you जो गाजीपुर में पहाड़ी है यार, कूड़े की पहाड़ी, लैंडफिल, उसमें से जो मट्टी निकालते हैं, उसमें से हमने नए कंपाउंड्स निकाले और लगता है उनकी कंडक्टिविटी बहुत हाई है, उनकी डाइपोल मूवमेंट बहुत हाई है और वो शायद अल्जाइमर्स, पार्किंसंस, डिमेंशिया में, एंड दे आर नॉट टॉक्सिक. पानी में घुलते हैं, थोड़ा सा पानी में पी लो. And I don't want as a chemist or as a teacher, I don't want to make money out of it. पर ये मत करना कि कल जाके पहाड़ी से थोड़ा सा कूड़ा लेके उसमें से पानी में डाल के पी लेना, ये मत करना. This has yet to undergo the required tests, namely in vitro तो result हुआ, in vivo हमें देखना पड़ेगा in vitro पहले कि ये सब जो मैंने कहा है वो सच है कि नहीं. उसके बाद बहुत केयरफुल स्क्रूटिनी के बाद हम इस चीज को ह्यूमन बीइंग्स में कर सकते हैं. पर केमिस्ट के हाथ में एक चमत्कार है. Some people believe chemist can make any molecule that you write. उसे मैंने synthetic vaccines, I had referred to synthetic vaccines, not biological vaccines, which sometimes have deficiencies. You know that COVID-19 vaccines have now been proved to be causing heart attack in some people. It's been admitted in the court. हम कह रहे थे सिंथेटिक वैक्सीन बनाइए, 100% सेम प्रोडक्ट देंगे. और यहाँ भी हम इन कंपाउंड्स को कूड़े के पहाड़ी से नहीं बनाएंगे, हम लेबोरेटरी में सिंथेसाइज करेंगे, किलोग्राम में सिंथेसाइज करेंगे. कल के टॉक में यही तो बताऊंगा मैं कि ऐसा एक कंपाउंड और कहीं इंडिया में मैंने पौंडीचेरी में बनाया पिछले साल, इस साल, जो हमने किलोग्राम से बनाए. अच्छा, और हो सकता है वो चांद में या जुपिटर में या मंगल ग्रह में कहीं पाया जाए. जब हम कुछ नहीं जानते चीजों के बारे में तो हम कहते हैं बेकार है. अभी हम ऐसी चीजों को सिर्फ जला देते हैं. हमें इसका महत्वता, इंपॉर्टेंस, वी डोंट रियलाइज दैट देयर कुड बी सम पोटेंशियल. Surprisingly, we are ignorant on many of these things. Once I have proposed a structure for GLF NSIC 14, GLF NSIC, GLF, chemists all over the globe. Once these structures are published, we'll try to make them in the laboratory very safe manner. I think we are almost towards the end of our talk. Next slide, if there is any. Well, इतने जगह आप कंडक्टिंग पॉलीमर्स को यूज कर सकते हैं. हम एक प्रोजेक्ट शुरू कर रहे हैं कोयम्बतूर में. एक यंग मैन आया है विद PhD फ्रॉम Arizona State University. He came to me twice with his father. हम fabrics बनाएंगे, dresses बनाएंगे, जैसे soldier है. He's fighting on our borders against, say, Pakistan, China. He can't be washing his clothes every day and putting them to dry. And that will give his location also. Whereas we make antibacterial fabrics, we coat the fabrics, so the fabric will never get any bacterial infection. Or for that matter, we make smart fabrics. We make nano devices. Say, for example, the carbon nanotube, or from the fullerene that I referred to the other day, or the cheaper version, reduced graphene oxide. India भर में चर्चा हो रही है, हर जगह चर्चा हो रही है कि दो चर्चाएं बताऊं, two discussions. Sir, ग्राफीन पे काम कर रहे हैं, ग्राफीन पे काम कर रहे हैं, सच बताओ. अभी एक यूनिवर्सिटी में उनके प्रिंसिपल को मिलने जा रहा हूं, हिंदुस्तान इंस्टीट्यूट ऑफ टेक्नोलॉजी एंड साइंस, उन्होंने नोबेल लॉरेट को बुलाया, बहुत बड़ी डिस्कशन हुई. IICG, Indian Institute for Center of Innovation for Center for Graphene, IICG in Kalamassery. Huge amounts of money have been invested. They asked me all questions, all kinds of questions on microelectronics. This is aimed at nanoelectronics. पर मैंने पूछा ग्राफीन कब बनेगा आपके यहाँ? कहते 2 साल में नहीं बने. हम कह रहे हैं 2 साल के अंदर हमारे पास जो वाटर सॉल्युबल नैनो कार्बन मटेरियल्स हैं और दूसरे कंपाउंड्स हैं, उनको लेके हम स्मार्ट फैब्रिक्स, एंटीबैक्टीरियल कोटेड फैब्रिक्स, सॉक्स, ड्रेसेस, टी शर्ट्स, हैंडकरचीफ्स हम बनाएंगे. मैं चाहता हूं कि इनको, मेरे को सुनाई दे रहा है, आपको नहीं सुनाई दे रहा? ये हमारा मोरलेस एम है अगले 2 साल में, और बहुत सारा काम कर रहे हैं, पर ये भी एम यहाँ है, because Coimbatore, where I am talking to you from, was referred to till very recently as the Manchester of India. But unfortunately, all the spinning, weaving mills have closed because we have been overtaken by other countries and competitors. Are we at the close of our lecture as we hit the hour? Next slide. May I just show you 1 or 2 things that I have published in the recent past, where you can read where the emphasis has been on isolating compounds of valuable compounds for technological uses from soil. This one is from municipal city solid waste. And tomorrow's one will be on a form of a source of a material that is available in the world and in India and many places in tonnage quantities different from today's source. That also has been patented by us. Shall we close the lecture, or you want to put up the last slide, young man? ये हमारे publications हैं, patent applications हैं. एक paper तो publish हो गया, pyrethylene type compounds from the municipal solid waste Ghazipur landfill inert soil as brain and cancer 5-HT receptor binding agents. God alone knows whether this will be proved. We have submitted another paper mentioned at the bottom, and the previous publication is also shown that we could have these. We have submitted this as well, recent progress in materials 2023. So let us see how we proceed from here. What I want to conclude is I will work from Coimbatore and occasionally Delhi. My young team will work in FITT, IIT Delhi, and we will coordinate. Whenever there is a need, I'll rush to the lab and do experimental work, continue to do some work in Coimbatore as well. May I now thank the organizers and all of you for being patient for this entire, nearly a shade less than an hour. And I have communicated to you a few points which I need not rub again and again. कूड़े से waste to wealth. सिर्फ ब्रिक्स बनाना नहीं, वो अच्छी चीज है, रोड बनाएंगे, पर हम कह रहे हैं शायद वैल्यू एडेड प्रोडक्ट्स for new technology, nano devices, for micro devices, for medicine, for material science, for studying fundamental processes like electronic conductivity, its variation with pH, before and after doping, Can we do all these fundamental studies, yet show for that matter that we can measure in a laboratory dipole moment? It's rarely done in India. I had a friend of mine who was working in this in Nagpur long ago, but I don't very often today. Most people do only computational studies. अब मैं आपको बताना चाहता हूं कि मेरे ऊपर जो इल्जाम लगाया गया कि आप माइक्रो इलेक्ट्रॉनिक्स कर रहे हैं, मैं कह रहा हूं माइक्रो इलेक्ट्रॉनिक्स नहीं, नैनो इलेक्ट्रॉनिक्स में हम कर सकते हैं। पर अभी क्या हमारा स्टेट इंडिया इसके लिए तैयार है? आई थिंक आवर पॉलिसीज आर यू इंपोर्ट एवरीथिंग फ्रॉम अब्रॉड एंड सेट अप अ फैक्ट्री। तो डिस्कवरी कहाँ होगा हमारे देश में? कहाँ होगा डिस्कवरी? कौन यंग आदमी एनकरेज होगा कुछ कर? थैंक यू सो मच फॉर योर पेशेंस।
If anyone has any questions, please feel free to ask.
कोई पूछे, कमेंट करें।
Actually, it's very fascinating topic. It's not complicated, but to think that from a heap of trash, we are trying to find out something productive really fascinates. Is a very fascinating theme actually.
Very kind of you to say so.
Sir, I'd like to read the question. Since the primary waste product in the landfills is plastic, why do we not set plants to make fuel using the already known method of no oxygen combustion?
You are presuming in this question that plastic is the main component of this pahadi. Is that the presumption? Before they process, if I'm not mistaken, they remove the plastic. So this entire work is not based on plastic waste products. The process that happens before the material is given to us, they segregate these things. And I do not think, Sujit, would you agree with me? Plastic to उससे पहले हटा देते हैं शायद। वो सेपरेट टॉपिक है।
Hello.
इनर्ट साइड, हाँ बताइए।
Yes, sir. The plastic is filtered, and we take the inert cell, whose dimension is 90 mm. 90 mm. Yeah.
And there is no plastic in our starting material, huh?
No, but little bit plastic material is available, which we can just take out from that our material before processing.
Next question. You can ask a subsidiary question, Rohan, if you wish. इसका एक पूरा प्लांट लगा हुआ, बहुत बड़ा प्लांट ईस्ट दिल्ली में एक मेट्रो स्टेशन के साथ है। मैं उस स्टेशन का नाम नहीं याद आ रहा मेरे को, तो
जाफराबाद
है, जाफराबाद मेट्रो स्टेशन के साथ बहुत बड़ा प्लांट लगाया। So I was told you I can take a lab there and do my work, but to transport myself each day about 30 kilometers or 25 kilometers one way in the city of Delhi was not very attractive. And then receiving 10 trucks of kooda every day would also be quite a challenge. पर ये कोई और करे, mechanical process, automated process, तो जरूर अच्छा। Next comment or question. Thank you for your question. It's a very precise question. Why not do some work on the plastic, burning, etc. अलग सवाल।
Sir, the next question has arisen from Kirti R. I would like to read it. Sir, countries like Sweden are converting their waste into energy. Why we are not using that technology or working on that technology and use waste aggregates in Ghazipur or Jahangirpuri to convert them into energy source?
बहुत अच्छा सवाल है। Answer is very simple. My young friend Kirti R should go near my house where I lived after retirement till I came here last December. And that was just about 2 kilometers from Kalpraji extension, from the Crown A Plaza Hotel, Okla Phase 1. At the turn, we have a huge plant of using this very material that you mentioned in Jahangirpuri and Ghazipur, but in the Okla setup, they have a technology taken from Denmark, and they are producing electricity. You can see the plant from the metro when you're traveling towards Faridabad on the right-hand side, or when you're coming from Faridabad on the left-hand side. So, but again, there is a problem. So many trucks bring this kuda every day, and half of the kuda gets dropped inside the city. That itself is a problem, but they are converting it into electricity. So your question is answered. Ghazipur is not doing it. Jahangirpur is not doing it. But Denmark se technology ke saath, we are producing electricity in Delhi, in Okhla, landfill. वो भी इतना ही बड़ा पहाड़ी है. Whenever you go past these landfills, you have to close your windshields and your windows in the car because it stinks. पर बहुत सारे लोग उनके पास रहते हैं, पॉपुलेशन है, और क्या उनकी हालत होगी, उनकी स्टेट ऑफ हेल्थ मैं नहीं जानता हूं. पर ओखला में फेस 1 में बदरपुर के पास प्लांट है जहां कूड़े को बिजली में कन्वर्ट कर सक्सेसफुल. नेक्स्ट कमेंट. वेरी गुड क्वेश्चन इंसिडेंट. Rohan, you want to make a statement? Rohan, please do so on your own, or his comment can be read out. He has a subsidiary comment.
So I would like to read the same. His suggestion is, since you have not decided on the shape name for the GLF, I would like to suggest the name Claw Morningstar.
Huh? Please
Claw
repeat.
Morningstar.
Huh?
Since you have, I would like to repeat, sir. Since you have not decided on the shape name for GLF, I would like to suggest the name Claw Morningstar.
यार ये समझ नहीं आया, दोबारा बताओ. फर्स्ट वर्ड क्लियर नहीं है. मॉर्निंग स्टार क्लियर है, पहला वाला क्या है? जी.
Claw.
हाउ डू यू स्पेल इट?
CLA. Claw. CLAW. Claw.
CLAW. Claw. I don't know the word.
No. CLAW.
Claw. Oh, CLAW. Claw. And morning
Yes.
star. Remarkable. Yeah.
Yes, sir.
Anyway, we'll think about it, suggestion, and we'll remember it. I hope he will also reflect on these thoughts and maybe give us, among other many names. You have heard me talk about Vishwamayin, my molecule, Pularazirma. I should not say my molecule, our molecule. We have Gwal Pahadi acid, which we discussed, our molecule. तो इसका भी नाम देखेंगे जो ये सजेस्ट कर रहे हैं कि क्लॉ मॉर्निंग स्टार. Yes, his point is good. You know, all these chemical names, systematic names are, बताइए. It looks like a weapon. He says it looks like a weapon. That's a bit dangerous. It is a weapon for curing brain diseases. तब तो मैं तैयार हूं कि भाई ये क्लॉ कर जाता है जाके रिसेप्टर में और सेरोटोनिन या एसिटाइल क्लोरीन एस्ट्रेस में बाइंड कर जाता है और बीमारी को खत्म कर देता है. All of you know, for all these बीमारीज, Alzheimer's, Parkinson's, dementia, there is little or no cure. You have only what is called symptomatic care. That means सिर में दर्द है तो पैरासिटामोल दे दो भाई, क्रोसिन दे दो. दवाइयां नहीं है अभी. चलिए, और कुछ है शंका? एनी कमेंट्स, एनी डाउट्स? सुजीत, आप कुछ बोलना चाहते हैं जल्दी से संक्षिप्त में, क्यों हमारा टाइम हो चुका है.
जी सर, पहले तो रोहन का अच्छा एक सजेशन है. थैंक यू फॉर द सजेशन. कि और उसको थोड़ा सा शार्प आपने किया कि हाँ, अगर ये वेपन न्यूरो डिजेनरेटिव डिजीज को करता है तब तो बहुत अच्छा है.
रोहन has a comment. Please read its comment out.
सर एक
he
चीज
has
और
written,
रोहन पढ़ो. रोहन का.
you showed the application of GLF in smart fabric. The main concern for this is the battery. So I would like to suggest the use of solid foldable batteries that can be cut to desirable shape.
Well, very good question. यार बहुत अच्छा क्वेश्चन है. आंसर बड़ा मुश्किल है क्योंकि बैंगलोर में एक कंपनी है, उसका ओनर इज गदाधर रेड्डी. You can see a video of his in the internet. Mr. Gadadhar Reddy, Gadadhar, Gadadhar Reddy. He may be about 40, I don't know how, but quite young relatively. The name of his company is called NOPO, Not Possible Technologies. But he's producing 100% pure single-walled carbon nanotube. So I spoke to him on one occasion. He said, give me your things. I will make batteries out of it. So that means the batteries that my Rohan wants, which can be cut, which do not explode when they get overheated, as in your mobile phone. If you keep it to the charger, chances are that when you're sleeping, the lithium battery will explode. Nowadays, people are going for the sodium battery. Delhi is trying to use the hydrogen gas as a fuel, which is also highly explosive. But I think we have changed technology. So he's asking the question, देखा जाए तो सच में यही है कि हम बैटरीज बना सकते हैं. हाँ, बना सकते हैं. मैं 2-3 बारी गया हूँ. उसकी जो डायरेक्टर जनरल CSIR की, she has come from SECRI, Central Electrochemical Research Institute. They focus only on batteries and so on. And she has great success in making batteries, lithium battery, sodium battery, and so on. इनका सवाल है, आपके मटेरियल्स के साथ क्या बैटरीज बना सकते हैं? क्यों नहीं? पर मेरे पास इस पे अनुभव बहुत कम है. Experience is very little. But my Mr. Manubhav Arya, working for his PhD, in fact, his joint co-supervisor is Dr. Vengarong from the University of, Deakin University, Australia, who is a very accomplished electrochemist. पूरा यूनिवर्सिटी का स्ट्रक्चर इनके हाथ में है. तो इसको जो भी इलेक्ट्रोकेमिकल चीज बैटरी बनानी हो, कुछ भी उसको एनालाइज करना हो, शायद मनोरभव और सुजित मिलके इंडिया में और ऑस्ट्रेलिया में मिलके काम करें, और दूसरे लोग सेंट स्टीफन से आके हमें ज्वाइन करें. रोहन जैसे हमारे को स्टूडेंट्स मिले जो हमको सवाल पूछे और हमको जवाब देना पड़ता है कि मेरे को बैटरी बनानी नहीं आती. सीखो, सीखनी पड़ेगी, हम सबको सीखना पड़ेगा, उसको पूरा पढ़ना पड़ेगा. पर इंडिया में काफी इस पे कोशिश हो रही है. There's a lot of research going on, especially I have mentioned Central Electrochemical Research Institute in Bengal, in several laboratories, in Indian Institute of Science, many IITs, many ICERs. So batteries are the focus of attention, not only for mobiles, for all other electronic or microelectronic or nano-electronic gadgets. Good question again, Rohan. Thank you for your searching questions.
सर, एक अजित सर हमारे ऑडियंस में हैं. मैं चाहता हूं कि आप.
मैंने देखा नहीं, मैं नाम नहीं देख पाया सर. मैंने जिन्होंने उनको पहले भी मैंने इंट्रोड्यूस किया था, मिस्टर अजित सेठ has done BSc Honors Chemistry, St. Stephen's College, 1970, 73, 73, 75. He did his MSc from Delhi University. Then he cleared the IAS, and then serving in different parts from the UP cadre, he rose to become the Cabinet Secretary of Government of India, which is the #1 post any civil servant can hold. Ajit, we welcome you once again. If you wish to make any remark or any comments, we will value your thoughts and your comments very much if you wish to. There is no compulsion on you to do so.
Thank you, sir. No, I have joined this meeting as always only as a listener and as a, if I can say in quotation marks, a student. So it transports me back to days in college, and I feel young again. So it is so energizing and uplifting. I won't say that. I mean, not in my situation. I don't think I'll say that I'll be able to do all this chemistry, or that I even understand 100% of it. But then 5 years of chemistry and 1 year of MPhil has certainly, given me the interest to follow these things. And more than that, I want to follow you, whatever you say. So I just want to thank you. I just want to thank you for the light that you throw on various subjects. That is something remarkable. 4 जनों से हम भी चर्चा करते हैं कि देखिए आप, you wouldn't have seen a teacher like this. So they also marvel. They said, अरे वो अभी भी वो इतना interest देते हैं. I said, हाँ देखिए. So, but anyway, I mean, I'm just grateful that I and even Amal, we tune into your talks and we enjoy it. And we have one or two times some guests were there in the house, so I compelled them also to listen. I said,
Very kind of you, and extremely humble statement from an achiever who does not speak much about himself, but puts it in the passing remarks. But इन्होंने बहुत अच्छा कहा कि हम शुक्रगुजार हैं कि अजीत हमारे साथ रहे और हमारा एसोसिएशन 1970 से है. कितने साल हुए? 30 और 24, 54 साल से. ये सेंट स्टीफेंस की देन है कि the teacher and the taught, the junior member and the senior member remain in contact with each other. Is a very organic whole, and it's a seamless transition from a student to a teacher and beyond. Thank you, Ajit, for your presence. I
Thank
could
you,
not
sir.
see the moves. Thanks, Sujit, for pointing it out. Very kind of you.
Thank you, Professor Eswaran, sir, for delivering an enlightening and engaging lecture today. Your insightful expertise and passionate presentation have inspired us all. We deeply appreciate the valuable time and effort you invested in sharing your knowledge with us. Thank you once again, sir.
Thank you so much. You spoke so well. I thank you and one and all who was
Thank you,
present.
sir.
Thank you so much. We close this meeting.
Thank you, sir.
Bye.